Hey guys, this is the electrical hotspot. Helping you get around your examinations is our number one goal. And if you do like this video, please don't forget to hit the like button, share it among your friends, and also subscribe to the channel. Don't forget to press the bell icon so that you can get notified the minute I upload one. Let's enjoy electrical engineering, guys.
A very simple introduction to this particular microprocessor in the previous video. It covered certain topics such as the different buses that are there, the registers P, C, D, E, H, L, and the A register, and we also talked a little bit of its small part of its history. Well, to understand this particular video very thoroughly, I prefer you guys go back. I've put the link in the description below. Just refer to it. It's a very short video. You can go through it so that you can get the correct explanation. See, this is your roots. Now onwards, from this entire chapter, you're going to have programming. And when it comes to programming, and you know the architecture properly, it's going to make life so much simpler for you guys. So that's it about a small, take up line that I prepared for you guys. So let's just dive deep into what is going to be taught over here. Okay, so don't be afraid of this entire, large structure that you have over here. You may like think it's going to be very difficult, but in reality, it's very simple. I'm going to teach you step by step, and you go accordingly. Don't just copy this right now. Pause the video. Don't copy it. We'll go step by step. Each and every block I'll be explaining, and it will make it very simple for you guys. So watch throughout the entire video so that you won't miss any particular element. Everything is very simple, and you don't have to buy out anything if you watch this video through to the end. Okay, so let's begin. Okay, fine. See, I'll be like quite, highlighting the point. I mean, block that I'll be doing. I'm not doing, drawing it again because it will waste time. We have all the picture and just highlighting the points that are going to be drawn, that are going to be explained. Okay, so yeah. Uh, so let's start with the PC. Okay, hope you can see that highlighted. I have highlighted it in blue. Okay, this is PC. PC stands for program counter. Okay, so PC is a particular register. It's a register that is going to hold the value or address value of a particular instruction. That is not of any particular instruction, but of the beginning instruction. Suppose it is in the beginning of a particular program, it's going to hold the value or the address of the starting instruction. PC is going to hold the address of the starting instruction. Okay, before we go into this, let me just give a small brief introduction how this entire, okay, in very short manner. We have something called as the program counter. Don't look into this particular. Let's just go down. I'll do it in a better format so that you guys can understand. Okay, so okay, so we have something called as the program counter. Okay, PC will hold, it's a register and it holds the address value. Okay, this PC will send its address of the instruction through something called as the address bus. Okay, to what your instruction said, and it gets the address bus. Okay, and it extracts the instruction. Now the instruction that you have is not, instruction or the data that is taken from a memory will not be something that your microprocessor can understand. It is of the form of opcode. Opcode is can be hexadecimal or can be hexadecimal. Usually when you program in 8085, we are going to each and every action. Later on in programming, you will see many actions such as move A, comma B. You can see add B, etc. Sorry, add. I'm sorry about that. 1 minute. Okay, you see add B, Okay, this add B signifies a particular instruction. This instruction, if you just type it to the UP, then I mean the microprocessor, it can't understand. Okay, so guys, I'll be calling microprocessor MUP in case that you may fall out. MUP. Okay, so the MUP can't understand very clearly what is add B. It will have a particular opcode. Okay, that opcode is retrieved from this address bus. Opcode goes to something called as the instruction register. The instruction decoder. Instruction decoder. It decodes and it carries out the functionality. So this is a very brief description of what is going to happen in this entire picture over here. Okay, so let's dive straight to it. We have the program counter. Okay, 1 minute, guys. Yeah, we have the program counter. And this program counter holds the value of instruction, next instruction. It sends this particular instruction, forget all other concepts, okay? We have the address value. It's a 16-bit register. Remember, the program counter is a 16-bit register. It sends this address through the address buffs. Okay, these are called as the address buffs. This and this are address buffs. Okay, it sends the instruction through, not address through this address buff. Okay, now your registers in an 8085, if you saw my previous videos, are all 8 registers. Okay, so we are having two separate address buses, one for the higher order and the other for the low order. Now don't consider this deep. I will be explaining that in a few minutes time. So we have, suppose, an address that is 1256. 12 is the higher order and gets transmitted through this. 56 is the 56 is the lower order and gets transmitted through this. It moves to that particular address location in your memory, takes the particular data, and see D7 to D0. Watch my previous video. I state very clearly that the I state very clearly that your a data bus over there is an 8-bit register. So D7 to D0 is an 8-bit. This over here then signifies it is multiplexed. Both address as well as data can be sent through this particular buffer. It is an address data buffer. Okay, it is an address data buffer because it is multiplexed. Why we go for multiplexing? So what is actually multiplexing? Consider your multiplex theaters out there. It is a combination of several theaters into one, right? Similarly, you have many address buses and many data buses all integrated into one, and we are doing so that you're making the network very much simple. Otherwise, it's going to be very complicated. You have a separate address bus and you have a separate data bus. Okay, so that is why that particular address bus, that's the lower order address buff or the bus, is multiplexed with data bus. Okay, so this can transmit the data. Okay, this transmits the data through this particular external data bus. Now it moves into the instruction register, where that instruction is temporarily stored, and moves into the instruction decoder. I told you it is coming in. This instruction is coming in as a set of opcodes, which is decoded over here. This moves into the timing and control diagram. Now it has so much amount of pins. When you are asked in examinations about the architecture, I am very sure you don't have to explain all these pins, because these are the pins, and I'll be explaining every pins in the next video to come. So let's just forget about that in this particular video. Let's focus on what the timing and control system does. It sends in messages to all the different components of this architecture. Okay, now this is a very important aspect. It acts like a brain. It sends in messages to everything. So there are actually connections between this timing diagram to the temporary register, to everything, but we are avoiding to draw that over here, and we generally don't do it in examinations because of the fact that it makes your entire structure very complicated and unnecessarily add-ons. So it is just to be understood that to everything there's a that is to be drawn from the timing and control to every other component. Okay, so this timing and control gets in the decoded instruction and sends in the different time at which it has to carry out a particular instruction. Now let us come to the most important part, that is the ALU, or the arithmetic logic unit, and everything else. This can be properly explained by taking a particular example. Let us take the example of suppose the instruction is add b. Okay, you guys may be familiar with small amount of programming, so, or if you're not, stay tuned, I'll be releasing a set of videos on that. So just for now, bear with me, I'll be explaining what an add b does. Okay, so add b over here means b is added to something and it is to be stored in something. Do you get what I'm telling here? B is to be added to something and it is to be stored in something, right? So what is this something? That is the accumulator. Okay, so when you write add B, accumulator value is added to B and it is again stored in accumulator. That is why we are calling it as an accumulator. Take another example. Suppose you're having multiplication. What is multiplication? Repeated addition. There's no particular way in order to do your multiplication other than adding in a particular new b. So we have to do add b several times. So it is to be accumulated in one particular variable or one particular register, and that register is a special register called as an accumulator register. Always remember, this accumulator register is always going to be your first thing. Which one? Operand. Always. If you have if you have sub b, it means a equal to a minus b. Always the first operand is the accumulator. Okay. So the accumulator b is the first operand, and there is something called as the register select. When we give an instruction called as add b, register select will select a particular register. Here it selects b, and since it is so, we have b, c, d, e, h, l, w, z, etc. It has to be multiplexed. That selection is done by this register select, and hence it enables b to be transferred through the external data bus and get stored in the temporary register. So we have a value here and temporary register getting what b contains. Now whatever instruction is to be carried out is carried out under the ALU, which is an 8-bit ALU, and it is transmitted to the external data bus to wherever the instruction is to be stored. Suppose it is in this particular scenario in add b, it is to be stored in the accumulator itself. So it moves from the ALU, comes back to the accumulator value itself. So you understand how add b works in a particular 8085 instruction. This is what makes your programming life so much more simpler. Okay, now before we move into anything further, let me say, what do these flags represent? Okay, so that is again a very important topic, flag. Okay, that itself can carry a potential for taking an entire full video, but let me just explain to you guys in a much simpler manner and rum it out. Okay, I know it has been a lot of time till now, but I have to explain this, right? And it's interesting also. So your flags, you have mainly three different flags. You have something called as the, I'm sorry, let me change the color if it is not. Yeah, you have your zero flag. Okay, you have your carry flag, and you also have the I'm sorry, you have your zero flag. Okay, let me just explain what does the zero flag do. Okay, see, let's just go back into that this thing once more. See, there is this ALU that is conducting a particular operation. Okay, and suppose it is sub b. B contains 4. Accumulator also contains 4. And if you do sub b, the result is going to be 0. So the flag, 0 flag, will be 1, indicating that the current situation, the result has become 0. Similarly, for carry flag, okay, for carry flag, it is when your result, current result, remember this word called as current result, becomes equal to any particular value that actually generates a particular carry, then it is supposed to become one. The carry flag becomes one. Suppose you're adding two 8-bit numbers that actually makes a carry, then it will become one. Then we have the uh, sign flag. Okay, sign flag that gives a particular, from its name itself we can actually determine that it gives a value, that value equal to 1, or it activates when you have a sign that is being generated. Okay, so this is utilized in many situations. Suppose you want to, throughout the programming you will be coming to utilize all these flags. So I know speaking about that now is not going to make any sense for you guys, but I hope you guys, I have made my point clear here. Okay, so you understood the flag at least in a very minimal manner. I'm sorry I couldn't convey that because it takes a lot of time, and I'm bounded by time restrictions here. Okay, now just a quick wrap on interrupt control and serial control, which again can be explained in a large video itself. But for if the question is just to explain about the architecture, you generally don't have to write about these two, but just to make sure. Interrupt. What are interrupts? See, suppose you're writing a big program, and any such instruction, such as your in RST 5.5, RST 6.5, any such instructions occur, it is a request to the program to actually jump from the normal area of control to a particular address. Okay, to a particular address. This is called as interrupt, from its name itself, interrupt. Okay, so we have interrupt request, you have RST 5.5, you have RST 6.5, we have RST 7.5, and we have trap, out of which trap is the non-marks. Okay, yeah, I'm not going into the details of all that because it'll go on and on and on, and it's not necessary also when you consider the architecture of 8085. I'll be covering that in the next video. Okay, and you also have something called a serial control, where if you want to give in a serial input data, that is what this stands for. Okay, serial input data, and you have your serial output data from that particular UP. So a quick wrap up. You have yeah, I think I didn't explain about the, yeah, I'm sorry. Yeah, we are not done, it's still a lot more. Okay, we have B, C, D, E, H, L, which again from the previous video I told you were register pairs. Okay, these register pairs are can only operate in B, C manner, D, E manner, and H, L manner. Okay, B, C manner, D, L manner, D, E manner, H, L manner. It cannot operate. We cannot take it as B, D, or H, E, anything else but the order I just spoke about. Okay, see, if you want to take any 8-bit number, we can take B register, you can take C register, D register, E register, H, or L. No problem. When you want to reference it as a 16-bit, we have to make sure that we are taking BC, DE, or HL. Okay, and once you have taken it as a register pair, we can always take it as individual registers also. Suppose in one instruction you're using BC as a register pair, next instruction you're only wanting to reference to one register, that is B or C, anything, we can do that in 8085. Okay, now you may be asking, what is W and Z? W and Z are register pairs that are abruptly changed by the new P. Hence, we do not utilize it in any kind of programming. Okay, and yes, we have the function of the increment and decrement. See, I told you program counter holds the first instruction, and this entire progress it takes in the memory, goes through the external data bus, comes in, decodes, and then does the particular program over here. Now, while that is being done, what happens is that the program counter increments. It moves into the next address location, moves into the memory, takes that data and moves on. So that means your data, your instruction that is to be carried out comes in continuously. That is what is happening over here using your increment and decrement. Now, why doesn't the program counters always being incrementing? So what is the utilization of a decrement operation? Okay, that is when we have to talk about something called a stack. Okay, folks, this is the last topic, that is stack. Okay, it's a very interesting topic. Let's just come over here. Stack. Okay, now I'm not sure if you guys already know what stack is. See, consider a case of your Facebook wall or Instagram wall. Let's make things simple and nice for you guys. Okay, when you take those things, you see that. Suppose I'm posting a picture, and that picture I post at 4 o'clock. My friend takes a picture and he posts at 10 o'clock, and your mutual friend will come up and take his phone at 11 o'clock. He sees the photo that was posted by a friend first, right? That is called a stack. That is a basic concept of stack. That is, suppose you have a particular container, you put a particular stone inside, you keep on adding stones. Okay, it comes like this in a stack manner, and when you have to take out, it is the last one that entered last will be taken out first. So the concept of stack is LIFO, last in first out. So why is it utilized here? I told you data can be stored in registers. Now how many registers we have? B, C, D, E, H, L. Only that much. If you're doing big programming such as multiplication, division, so many programs that you're going to do with 8085, these registers are not going to be enough. You can now store it in an external memory location. You can store it in any particular location. Now suppose you want to retrieve that particular data, you are confused, where is my data? Okay, it goes into very complex programming in order to actually retrieve that particular data. So what do we do over here is that we are going to have an organized memory allocating process in which the data that is first stored over here, then we increment a particular pointer called as the stack pointer. That is what is seen over here. This pointer over here, stack pointer. Okay, this is incremented. Okay, I think I lost that. Yeah, so yeah, this is incremented and the next value is entered. Then it is incremented and the next value is entered. That is the function of a stack pointer. So I hope you guys got a good understanding of the architecture of 8085. Any problem, please leave a comment below. I'll be answering them individually. And guys, if you like the video, please give a thumbs up. Subscribe to my channel for great videos related to electrical and electronics engineering. I cover both. Okay, so guys, leave a comment if you like the video too. It really helps. Thank you for watching the video.